Welcome to Calculus AB video for skill number 146. I can find derivatives of exponential and logarithmic functions. The trivia question for the day is, what we have here is the French word for capital, chapiteau. And the question is, if we remove the I and T from the middle, so that we had chapeau, what would that word be in French? Alright, so in the last video we got this equation. We can probably come up with it real quick again. The equation of the line tangent to f of x is y minus y1 equal to m times x minus x1. Again, reviewing the relationship between position, speed, velocity, acceleration. Velocity is the derivative of position, and speed is the absolute value of that. Or if you wanted to, you could say the absolute value of velocity. And then acceleration is the second derivative of position, or if you wanted to, you could call it the first derivative of velocity. Just key facts to always remember. A lot of times we'll come back to that type of problem. So the power rule for derivatives, we learned that when we first started learning derivatives. Anytime you take the derivative, you can move the n down in front and subtract 1 from the power. For example, the derivative of x to the 6th is 6x to the 5th. The next rule is the exponential function, and in this case what we have is the exponent is the variable. So the derivative of this is a to the x times ln of a. For example, if we wanted to find the derivative of 2 to the x, we would have 2 to the x times ln of 2. If our base is e, we can use the same rule, and we just find that we have e to the x times ln, oops, I can't write today, times ln of e, and we all know that ln of e is 1, so the derivative of e to the x is e to the x. A quick review of the chain rule. When we're taking the derivative of something that's the chain rule, we take the derivative of the outside and we multiply that by the derivative of the inside function. The derivative of a log function, the derivative of log base b is going to be 1 over x times the natural log of our base. And if we apply that to the natural logarithm, what we get is 1 over x times the natural log of e, which is just 1 over x. I've put in the absolute value here to reinforce the fact that we're only able to take logarithms of positive numbers. For now, this is not terribly important, but later on when we start working backwards, that absolute value symbol is going to be vitally important to answering problems correctly. Let's apply some of these rules in our examples. Alright, so what we're going to do is 6 quick derivatives. We have 5 to the x. When we take the derivative of that, we remember that it is an exponential, and then we just multiply it by our base. So there we go. Logarithms, what we have is 1 over t times the natural log of our base, which means that would work here as well. We'd have 1 over 2x to the 5th minus 7x times the natural log of our base, but we need to remember that we're going to be using the chain rule here. So the derivative of the u is 10x to the fourth minus 7. So the red gets multiplied by the blue, giving us our full function. Looks like I made a typo there. That should be d over dx. Alright, next up, the derivative of e to the x is e to the x, and we have a function up here, so we need to apply the chain rule. So we're going to get the derivative is e to the 3x minus 9 times the derivative of what's inside, which is 3. Next up, we have the natural log of t to the fourth plus 7t squared, and we can take that as 1 over t to the fourth plus 7t squared, and since it's a chain rule, we're going to have to multiply it by the derivative of what's inside, so 4t to the third plus 14t. And the final one looks a lot like the one above. In fact, it's identical, so I guess I made a typo. Whoops. Alright, let's take a look at another example further down the page. Find the equation of the tangent line to f of x equals 3x squared plus 1 at x equals 1. So what we can do here is we first find the derivative. So we're going to find f prime of x. So f prime of x is equal to 3 to the x squared plus 1 ln of our base times the derivative of the inside, so 2x. And if we're evaluating this at 1, we have f prime of 1 is equal to 9 times ln of 3 times 2. Plugging that into our typical formula, we have y minus f of 1 equals our m, which is 18 ln of 3, times x minus a, or 1. f of 1 is 9, so we have y minus 9 equals 18 ln of 3 times x minus 1. As a side project, it might be fun to think of this as expanding our exponents, 3x squared times 3 to the first power, and see if our approach with that would yield the same results. And you would need to use the product rule, and that's a fun path that I'll leave to the viewer. Okay, when I was working through this problem on the side, I realized that it's going to rely on our ability to do something that we learn actually in the next skill. And because it's part of the next skill, I don't want to do this equation, but I still think it's worth practicing the skill that we're currently learning, so I'm going to give us an alternate s of t. And I'll keep it relatively easy. S of t is 5e to the 3t squared. That's much easier to work with. We want to find the acceleration, which means we need to find the second derivative. So the derivative of this function, s prime of t, is 5e to the 3t squared times 6t, right? Because the derivative of e to the u is e to the u du. du dx if you wish. Okay. Now that's just our velocity, but we want acceleration, so we're going to need to find out the derivative of our velocity. So real quick, I'll write this as 30t times e to the 3t squared. So now if we want to take the derivative of that, we're going to actually have to use the product rule. So the product rule tells us that we take the derivative of the first, and then we multiply it by the second, and to that we add the first times the derivative of the second. And there we have our second derivative. If I went about simplifying this down, I might have 30e to the 3t squared plus 180t squared e to the 3t squared. And since we're interested in evaluating our acceleration function at time 1, we can stick 1 into this equation, and we get 30e to the 3 plus 180e to the 3. If we wanted to clean this up a bit, we could factor in e to the 3 out. Well, 30 plus 180 is 210, so we'll just go with that. 210 e to the 3rd. There we go. And don't forget our units, meters per second per second. All right, so an easier example. If you want to come back to this after we learn the next skill, I'd be happy to talk to you about this problem. All right, thanks for watching the video, and the answer to the trivia question is chapeau is the French word for hat or other covering of the head. So you can see its relation to capital as the head of the column